5 is how you survive. I ain't trying to survive, I'm trying to live it to the limit and love it alive. Life ills, poison my body. It used to say, fuck Mike skills.
Hi guys, my name is Nako Nakatsuka. I'm a 4th year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So when we talked about ionic and covalent bonding, I mentioned how to draw Lewis structures very briefly, about drawing single electrons as a dot and then paired electrons as 2 dots. So I wanted to show you guys this table showing a bunch of different elements and what their valence electron Lewis structures look like, and I thought that would be helpful. But now I also wanted to get into the nitty-gritty of actually how to draw a Lewis dot structure successfully. And so following these steps will help you draw any molecule of your choosing. But let's start out with an example, NO3-. Step 1, count all the valence electrons. So let's do that for NO3-. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons, and we have 3 of them. So let's do times 3, and we get 18 electrons. And then we have the ion's charge. In this case, it's NO3-, so a minus means we have 1 extra electron, right? And so when you add all of these up, we end up with 24 electrons. So basically from here, we have to distribute these 24 electrons onto the structure. And so step 2, draw the least electronegative atom in the center with the other atoms spaced evenly around it. So the least electronegative atom, and remember when we looked at the periodic table before, we looked about periodic trends, and this is my very rough sketch of a periodic table. Electronegativity increases diagonally up into the top right corner. So knowing this trend, we know that nitrogen is more electronegative than oxygen. And so it looks something like this. So this is step 2. Now let's draw in the single bonds to the central atoms. So we have a single bond, single bond, single bond. Note that I drew this out like this instead of like this. And that's because due to electron repulsion, we want these bonds to be as far apart from each other as possible. Remember, electrons have a negative charge, and so you would experience negatively charged interactions if they're really close to one another. But we'll talk more about that in VSEPR structures. Okay, so now we have to complete octets with the remaining electrons for the outer atoms first, and then we add the remaining electrons, if we have any, to the central atom. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But then remember there's shared electrons here. 19, 20, 21, 22, 23, 24. Awesome, so we have 24 electrons. But then the central atom wants to have 5 bonds, right? Because it has 5 valence electrons. So we have to complete the center atom's octet. So I'll write that here as number 3. Complete center atom octet. So you successfully distributed the 24 electrons, but now we need to have an extra bond for the nitrogen. And so we can do this by using the lone pair electrons from an outer atom of your choice. So let's just pick this one, for example. We're going to take these pairs of electrons and move it down here. So now we have a molecule that looks like this. 2 lone pairs here, 3 pairs here. And this satisfies nitrogen's octet, the oxygen's octet, and everything looks great. And now from here, we can talk about resonance structures, which will be another video. But basically, in short, depending on which electron you moved in this step, a variety of resonance structures can be determined. For example, if you took it out from this guy or this guy, then we'd have a different structure, right? We could have this one, or we could have this one. But I'll talk more in detail about that in a later chapter. But for now, you guys should now be able to draw any compound, whether it's NO3-, CH4, HF, whatever it is, and you can count all the valence electrons, you can draw out the skeletal structure, and then you can finally start making the correct number of bonds in order to complete the octet rule for all the atoms involved.
Yeah, this shit is wicked on these mean streets. None of my friends speak. We all trying to win. But then again, maybe it's for the best though. Cause when they see